Hello, Math 136 students. I am looking at analytics from the whole semester, kind of looking back to see weeks 1, 2, and currently what is going on in week 3. And again, this doesn't mean no one struggled with any questions at all, but as a group, it did not flag any topics in week 1 or week 2 for me as things that were major struggling points. Eventually, students were getting the questions correct at a rate that it considered acceptable. So if you are struggling from something in week 1 and 2 that you specifically want some content on as you're heading into studying for your midterm, send me an inbox to let me know, and I can look into that for you. But this did get flagged in this current week's assignments for week 3. It was flagging the quadratic functions with transformations, and it was also flagging analyzing the polynomial functions. So I wanted to just do maybe 1 or 2 questions from those homeworks that got flagged as difficult topics. Now, some of you may not have completed this homework yet, but hopefully this will help. So it says graph the function f by starting with the graph of y equals x squared and using transformations, shifting, compressing, stretching, and or reflecting. If it's necessary, it's not already written in this form, write it in that form for yourself. So notice they do already have it in this form. You just have to understand that there is a 1 in front of that. That's your A. So when you're dealing with transformations, anytime you have that parent function, this is the parent function, x squared, if there is a plus or minus something inside the part that's being squared, that is shifting either left or right. And it's opposite to what you see. So if you see a minus, you're going to be shifting right that amount. If you see plus, you're going to be shifting left. Notice we see a plus. So I'm already going to write that this is definitely going to have a shift left 2. Okay. Now, if you have a K at the end, that is it's after it's been squared. So it's after all of this has happened. That is going to be shifting up or down. And it is exactly what you see. A plus will make you go up the y-axis on height, and a minus will make you go down. So ours is actually going to be down 7. Now we need to talk for a minute about because if I was doing this in order, this part would happen first. That's inside the squared part, because that's how you do the order of operations. Then we would talk about the coefficient out front and see if anything's going on with that. Then after that, you would do order of operations. You would then shift down 7. That's how you would actually go through the order. Now, if there is a number other than 1 up front, if it's bigger than a 1, you're going to have, remember, a vertical stretch. You're growing really quickly. If it's less than 1 but bigger than 0, you'd have a compression. If you just have a 1, it's the exact same shape as the original parabola. Now, if there's a negative attached with that, the negative has nothing to do with the stretching or the compressing. It would be a reflection, okay? So, and that would be reflecting us across the x-axis because it's affecting our y values. So notice there's not anything there. So this is just these 2 things, but we need to put them in the correct order. So let's read our choices. The graph of y equals x squared should be shifted horizontally left by 7. That's incorrect because it was not shifting left by 7, it was by 2. So we can throw this one out. The graph of y equals x squared should be shifted horizontally to the right by 7, again, using the wrong number and also the wrong direction. The graph of y equals x squared should be horizontally shifted to the left 2, that's correct, and then shifted vertically down by 7. So notice this one has all of the correct directions, okay? And then if we click, which I have to actually click on it, check my answer, you'll notice that that's good. Okay, now it wants me to graph it. Now I like to make the graph big for myself. So you're needing to pick this parabola tool, and let me make sure, actually, I don't know, sometimes it doesn't share the graph. It looks like it is. Okay. You need to pick the parabola tool since we're doing the x squared shape. And we need to find, remember, the original parabolas would start at 0, 0. So we need to shift that left 2 and then down 7. So that gets us to right here. It didn't want to shift. If it doesn't shift for you, when you go to click it, you can change that right here. You can do the vertical shift was down 7. It's just in that order. And then the horizontal shift was left 2. So notice that's exactly where I wanted my point to be. I do not need to reflect it. We never had a negative in front of our parentheses or in front of our x. That's where you could shift, or excuse me, reflect over your y-axis. And we didn't have any stretches or compressions. So this should be the correct transformation. So we'll save that and check our answer. Okay. Now I did want to do the second one in this group as well, because like I said, these two individually were marked as troublesome ones. Okay, so this one wants us to jump straight into graphics. So I'm noticing a +2 inside there, so that's going to be left 2 and then down 3. So just double checking. I want to double check that that's still sharing that picture. It looks like it is. So again, I'm going to go ahead and just click here because I notice now it's going to make me do this. So left 2 and then down 1, 2, 3. Okay. Again, no reflections, nothing else going on. It was just horizontal shifting and vertical shifting. Save that and check answer. Okay. So like I said, those two got marked for me. I don't know if it was just maybe people missed them getting used to it. If you miss something a lot of times when you first start, sometimes that gets it marked. But those two were marked on my list. And then in the other homework, I had the analyzing polynomial functions. These two were marked as ones that were giving people trouble at the beginning. So you may have already gotten this eventually, but it was marking them as troublesome. So I like to, when I look at these, I like to have my information in order from highest power down to lowest power. So I would rewrite that if it was me. Just helps you see which parent function you might be modeling off of. This is a negative x to the third because that's a higher power, and this is a positive x. So I'm just going to rewrite them in their descending order. So when you look at it now like this helps you figure out what parent function we're dealing with. We're dealing with the x cubed, but it's the reflected one, the negative one. So this is negative x cubed for that part. So I'll actually type that in so we can see the next question. Because on these, this is a multi-part question. So if we type in negative x to the third, go to the next part, then it's going to ask me for my x and y intercepts. Okay, so and I don't love this because sometimes my math lab will ask you for ordered pairs, which is technically, if I was teaching this face-to-face, that is exactly how I would ask you for your ordered pairs. They should, or for your intercepts, they should always be ordered pairs. But just read your blue, always read your blue directions. They just want you to write the values as integers or fractions that are simplified and comma separating them. So you're not writing them technically in their correct form as an ordered pair. So we're just going to be looking at how do we find intercepts. So when you're trying to find x-intercepts, your y, which is your f of x, becomes 0. And we try to factor what's on the other side. So I can pull out I always pull out a negative if it's my leading coefficient, and they both have an x in common. That would make this x squared minus 1. That factors again because that's a difference of two perfect squares. That would be x plus 1 and x minus 1. We set each of those equal to 0, so that's going to be 0, a -1, and a 1. And I usually type them in order from least to greatest. Doesn't necessarily mean, I don't know if it'll count it wrong if you don't, because they didn't specify that. So that's my intercepts for the x. To find your y-intercept, you plug in 0 for the x's. So y, you want to think of f of x as y, because it's -0 cubed plus 0, so that's just going to be 0. So, and that makes sense because the origin is also 0, 0 for the x-intercept. So, and again, they're not making you write it as an ordered pair, which makes me a little mad, but that's how they want it on these. Okay. Determine the zeros in the functions and their multiplicities. Now, I had a video about this when I posted my instructor video content stuff on the Monday announcements. But essentially, here's how it works. Every time you factor these, you can kind of see what's going on. When you have it in non-factored form, if your degree is odd, which is ours, our highest power is odd, and your leading coefficient is negative, that has the following relationship. It looks like x cubed, but it's flipped the opposite direction. X cubed goes from increases from left to right, so we'd be decreasing. If you have a degree that's odd and a plus, this one would be down, this side would be up. These are called end behaviors. If you have an even degree, so say that I've been the fourth power, you would be doing both of them either up or both of them down. If the leading coefficient is positive, they'd both be up on the ends. If the leading coefficient is negative, they'd both be down. So we're dealing with this case, odd and negative, okay? So that's going to help us with our graphing in a minute. But when we look at the actual individual zeros and how do they function, you look at the degrees on each of these. Since these all factored into just one of each, they each have a degree of 1 or a multiplicity of 1. So that means when we go to cross or bounce, that's what we call it, If you have an odd degree, you cross the x-axis at that specific point. Now, if it's a 1, you cross almost like a straight line. It almost looks perfectly straight. If it's any other odd power, like 3 or 5, you kind of cross a little bit like x cubed, kind of squiggly, kind of like that, okay? If so, this would be odds that are 3 or bigger. If it's just an odd with a 1 power, you cross like a straight line. If you have an even power for some reason, so after you've factored them completely, if this is a 2 or a 4, if any of those powers are even, you bounce. So odds look like this when you're looking at the individual powers, and evens, and this is like on our x-axis. So imagine this being the x-axis. The evens bounce. So if you're down, you'd hit the wall and bounce back. Okay. So all of ours are odd. So I usually write a little chart about this. I put them in order from least to greatest. So these are my zeros. I just put Z for that. And then this is the multiplicity. So -1, 0, 1, they all had a multiplicity. I write it as a word, so I don't think this is an ordered pair. The multiplicity just means how many factors did you have of each one. And so we're going to cross the x-axis at all of these. Okay. And then it says, use the information to determine whether the graph crosses or touches the x-axis at each intercept. Our zeros are our x-intercepts. So I'm guessing they're just going to have us retype those. Oops, a decimal. Easy typo that would have gotten me points off when I tried to check it. Okay, and then we're going to fill in that information. So the smallest of the zeros was a 0 of multiplicity 1. So the graph crosses the x-axis at -1. The middle 0 is also a multiplicity of 1. They all had a multiplicity of 1. So the graph also crosses, and I'm just putting them in order from the chart from least to greatest. The largest 0, which was 1, has a multiplicity of 1. And so that graph also crosses at, and that was x equals 1. So notice my zeros are my x's, but the multiplicity is how many times did each factor occur. Okay. All right, and then I'm pretty sure that it wants us to ask this question. So your maximum number of turning points is always 1 less than your highest degree. So we can have at most 2 turning points. Okay. And then we're going to graph it. Okay, so this is where we needed that in behavior information to help us. So this one's supposed to behave and like in a polynomial. So this graph, notice, has this polynomial kind of multi-point thing. Okay. So I usually plot my intercepts. So we have -1, and then we have 0, and we have 1. Okay. And I'm wondering if I can plot points in between. I might have to go back. So you might need a table of values, or we can just, yeah, we can just do this possibly. We need one other point to show where this graph's going to be. So pick -2. Plug -2 back into the original function. That will help it know what it's doing at each of these. And so like -2 would be -2 cubed is -8. Then there's a negative in front of it, so that'd be +8. And then plus a -2, so that's going to be 6. So that first point, -2, is going to be up here at 6. Okay. Now, let's see if that's enough. I do want to double check this. If we plug in +2, do we get this -6 answer? If you plug in +2, you'll get a -8 plus a 2. So I believe once we get that final point other than our x-intercepts, because sometimes these graphs can be a little tricky, I think we're good. So let's save it and let's check it and see if that's good enough. Okay, so that one was fine. So let's look at another one, because like I said, it marked 11 and 12 for me as ones that people had been struggling with. So let's clear out all of our drawings. This one's already in descending order. So, and this one's behaving like a positive 1x cubed. So we can just put x to the third, because there's no negative in front of my leading coefficient. Okay, so check that answer. We need to factor again to find our x-intercepts. So I can pull out an x out of that function. That would leave me with x squared plus 4x minus 5. This is a trinomial. We can see if we can factor it again. So that's x plus 5 and minus 1, I believe, will work. Yep. Multiplies -5, adds to 4. So if we set each of these equal to 0, we get x equals 0, a -5, and a +1. So you're just solving each of those. So again, I write mine in order from least to greatest. So that would be the -5 first. comma, 0, comma, 1. Okay. Right? And then our y-intercept is when we plug in 0 for all the x's. If you plug that in, you're just going to get 0, which makes sense. If 0 is one of your x-intercepts, it is going to be your y-intercept. Okay, because it's the origin. All right, the zeros of the function are going to be those same x-intercepts. They're all real numbers, so those are our zeros. That's where we cross the x-axis. Okay. And now we're going to talk about each one. So each one of these also has a multiplicity of 1. So it's going to be the same thing. We have a multiplicity of 1. The smallest 0 is -5. So that's going to be crossing at -5. The middle 0 is also going to have a multiplicity of 1. Each one of these factors only happens once. So we cross at x equals 0. That was the middle x intercept, or 0. And then the largest 0 also had a multiplicity of 1. The factor didn't have a squared or a cubed on it. It was just power of 1. So we're going to cross. They tried to change the order on me there at 1. Okay. This is also cubed. So at most, the highest power was 3. So the most number of turning points is always that -1. And then let's graph it. So I'm going to enlarge my graph, move it over. So let's plot those, get our polynomial function. We're going to plot those points. We had a -5, a 0, and a 1. And then I'm going to maybe find a point. And oh, I didn't talk about the end behavior. Let me write that down. This is a end behavior is odd and positive. So we should be down on the left and up on the right. Otherwise, you won't know where your points are probably going to lie if you don't plug in the right things. So we're looking at plugging in, maybe I'll plug in a positive one this time. Let's plug in 4, okay? So if we plug in 4, or actually maybe 3. 3 cubed is 27. And then we would have 3 squared, which is 9, times 4. So I've got 27 plus 36. And I would do this on my calculator. And then 5 times 3 is 15, so -15. That's going to be way off the chart. That's 48. So that's way up here, and I can't even graph that big. So maybe we try 2, okay? So 2 cubed is 8. 2 squared, I'm plugging it into the original function, is 4 times 4 will be 16. And then 5 times 2 is 10, so -10. So that gives me 14. At least that's one I can plot, and I can kind of see it, that it's telling me that's at 214. Now, we need to double check this. I would check maybe -3 and make sure you get something close to 24 to make sure, because it's down on the left and up on the right, but I like to double check that this looks like it's close to that. Now, it's not exactly 24. That's going to be actually a little bit more towards in the one step off of that, but at least -3 could tell us if we're close. So -3 cubed would be -27. And then plus -3 squared is 9, so plus 36, and then plus 15. So that is 24. So actually they're saying it is that. So it didn't exactly plot it perfectly for us, but it should be hitting 24 at that -3. And that may not be the highest point. Maybe the highest point is a little higher than 24. It might be like 24.1 or something. But I've now got the confirmation by plugging in -3 that this looks like it plotted that correctly. All right, and we check our answer and we're good. So just be aware that these were not completed by everybody in the class yet, but I just, since nothing really got marked as an analytical class issue for weeks 1 and 2, I wanted to go ahead and look at what was kind of currently going on in your current homework. If you have any other questions, or there's a specific type of problem that you know you've struggled with as you start reviewing for your midterm, make sure you reach out to me through inbox. You also, remember, have a lot of review items to work through in Module 4. You have the practice quizzes, you have practice tests. There's a lot of things. There's a homework. You need to do all of that before you take your exam. So if you have your exam set pretty early in next week, in the week 4, you need to be working ahead as quickly as you can to make sure you actually review for the test. Don't go into that blind. Let me know if you have any questions. If not, have a wonderful weekend.